recording then officially. Never fails. Welcome back, folks. Welcome back to being in person. For me, at least. I didn't come here on Tuesday. A few more folks in the Zoom room joining us. We are in, let's see, lecture 1. I'm on slide 5. This is a greatest hits compilation from last semester designed to get us back into thinking about longitudinal analysis, time within person. So last time we introduced ourselves, we talked about the class, we remembered a few concepts, between and within. Remember that? Can someone give me an example? Like a variable and what it would mean to talk about its within part and its between part, and don't pick stress because that's my example.
Hunger.
Hunger. Ooh, I like that one. Go with it.
Throughout the day, hunger levels can fluctuate on an individual basis. So maybe I'm more hungry at 11 than you are.
More hungry at 11?
Between people, and then within people throughout the day, I can be hungrier at 9 than I am at 10 or things like that.
So within a day, your hunger may wax and wane, I think is the poetic way to say it, rise and fall. And then between people, some people are always hungrier than others. But in your answer, you also touched on something that hints at some of the complexity that we're going to see. You said at 11, right? So people may differ from each other more, like at 11 o'clock than they do at 3 o'clock, or vice versa. So what we think of as between is no longer a constant thing that comes with us. It's something that can depend on the time of day, the time of day of the week, occasion, whatever, all those other things. So between person differences may or may not stay the same over time. If they don't, then you got to worry about that. So I like that one. Yeah, I'm one of those people, like some folks are eating lunch. I'm not hungry when I first wake up, but about 9:30 a switch flips, and then I just start thinking about lunch. And so I may have lunch at 10 if I can't take it, because then I just can't concentrate. But then I'm not hungry again until like 5. So that's how it goes. Who else wants to play? Other examples? Emotion.
Some people positive affect, and some people feel more negative all the time.
So
for living person, maybe in the morning, I feel happy, but afternoon,
could be. So between people, some people have higher rates of positive affect or different rates of negative affect. I know those aren't the inverse of each other exactly, but they sort of work that way. And then within persons, if you are, some people are happier in the morning, some people are happier in the afternoon. So it varies within the day, and the type of variation can vary across people. Yeah, very good. Anyone else want to play? We got the idea? Okay, between is level 1 or 2? 2. Does that change depending on which class I'm teaching? It does not. Between is level 2. Within is level 1. The question is then between and within what? Right now, it's between and within person. Next fall, between and within cluster. But between being 2 and within being 1 always holds. Which one is the longitudinal part? Within, level 1. Yep, when you follow someone repeatedly, that's the extra information that the longitudinal sampling design is giving to you. Cross-sectionally, you would have already had differences between persons if you measure them once. Yep. So the next thing we're here to talk about is time-varying predictors, and all that vocabulary, having that cemented will really help you stay on it. Yes?
I think I just answered my own question.
Well, please answer it for us then.
Well, it was me. I don't think I've answered the question, but I think you're about to get into the question, because I was going to say, couldn't between person variation also differ over time?
Give me an example of how between person variation might differ over time.
Maybe like political beliefs or ideation.
Mm-hmm.
Like could maybe like proximity to an election or proximity to like new legislation being dropped, would that potentially drive some longitudinal between person changes, or because it's less systematic and that might be more fluctuation?
Could be either. So your first part of your sentence made me think of like a random slope. So like if people are spreading out because they're growing at different rates, the consequence of that is differential between person variation
But because
over
it's
time.
happening with that, like within that person over time, that's why you kind of focused on the within being the longitudinal part.
Mhm.
Got it. Okay, that makes sense. Thank you.
Yeah, it's so between person differences in time slopes is a little bit of both, because the time slope part is a within phenomenon. Like you only
Yeah.
need one person to measure change.
Yep.
But if you want to talk about how people differ in change, those are person characteristics that differ from each other. Like how much you change is a thing about you.
Okay.
So it's kind of like an interaction of both in that
Got it.
sense. But in terms of what would predict it, that would be between person things.
Okay.
So why do some people change in emotion the closer the election gets and some people don't?
Okay.
Maybe
Okay.
maybe political ideology is one, maybe background characteristics, etc.
Okay.
Yeah, that works. Yeah. Not that we're, worrying about that at all right now or anything like that.
Yeah.
Nothing interesting in the news these days. Everything is completely fine.
Mm-hmm.
Yep. All right. So yes, between and within. Next week, that's going to become really important because we'll talk about between person effects of a variable, within person effects of the variable, potential moderators of both of those things, and how we can figure out whether or not they're different or whether or not we would be able to combine them in some sort of way. The answer is usually not. Let's see. We also talked a little bit about what time is. That's going to be Unit 3, where we get into these details a little bit more and trying to separate out what are cross-sectional sort of age cohort or grade cohort differences from what is change within persons over time. Those are usually two different things as well. And this is the one that we ended on. This is one of my slides that shows up in each class. The big picture here, when we put in predictors and we talk about fixed slopes of predictors, all of that stuff is pretty much the same thing you learned in your very first regression class. Like a slope is a slope. The question is, how do we think about the variability around the slope, both in terms of sampling variability, but also within a study across people? And so the model for the variance, as I call it, I'll start the show here on slide 5. Hang on, screen zoomers. Yeah, I hadn't gotten to the slides yet, but I'm doing it right now, I promise. I was just talking out loud. There we go. Can you see them, zoomers?
Yes.
Cool, thank you. All right. So model for the variance, that's the big thing that differentiates longitudinal analysis and multi-level modeling more generally from standard regression types of things. We have different kinds of variance that we're worrying about. So we're trying to quantify and predict different piles is the way that I think about them, between person differences, within person differences, as well as differences between people in how they react to things and slopes for change over time. So this isn't the only choice. Multi-level models are not the only game in town for longitudinal data or dependent data more generally. So I want to make this connection because there are certain areas of research and disciplines that do not use random effects models as we've come to appreciate them. Like they don't, it's just not their thing. So in terms of how people would describe this problem from a more statistical point of view, we're worried about dependency. Occasions from the same person, repeated measures from the same person more generally show relationships, dependency, correlation. So if we don't pay attention to this, if we just fit a standard single level model with only one kind of error, then we know from a lot of previous research and probably some math that we will end up with standard errors for the fixed slopes that we care about that are some degree of wrong. And depending on how you've misspecified your model, they can look too good or they can look too bad. So that's well-covered territory. If you ever see longitudinal analysis done via regression, run away. Don't believe any of it. There's nothing right about that. However, what is less often appreciated is that the slopes themselves are likely to be incorrect as well. And that's because of this between-within thing. So if I wanted to predict how hunger relates to, let's go with negative affect. Like if I'm hangry is a word people use for that, right? When you're grumpy because you're hungry. Well, in that case, how hunger relates to negative affect as a person characteristic Like some people are more prone to being hangry than others. That's one kind of relationship. But then within a person, like when you're hungrier than usual, are you grumpier than usual? Those are two different kinds of relationships. So if I just throw hunger and affect into a model, the slope that comes back is going to be some amalgam of the two, or what I will quickly start to call a smushed effect, because it goes with this sort of gesture, where I've got between slopes at level 2, within slopes at level 1, and your model has to understand that those are at least two different things. So the slopes themselves can be wrong. The standard errors most certainly would be wrong if we ignore this problem. Oop, too much. However, there's about 3 different ways I can think of to fix this in terms of modeling strategies. And I'll talk about each of these briefly in turn. Fixed effects is one. Multivariate is another, or adding a level, which is random effects modeling. So fixed effects. This is very common in certain areas like econometrics. Also a little bit of this in, trying to think of how I would describe that, demography research, sociology research to some extent. And that is where you treat person ID as a categorical predictor. So there are routines in Stata in particular, as well as in other packages that kind of hide this from you. Like you set an option to say fixed effect in person, and then you don't ever see all of those slopes that related to person. They hide it from you. But functionally speaking, that's what's happening. They are removing the dependency by removing the people. The good news is that you can't really be wrong. The bad news is that then you can't explore why people differ from each other, because you've already saturated your model with respect to person differences. Your model now says that person 1 is different than person 2 is different than person 10 is different than person 15. Done. But then you can't say, are people with this ideology different than people with that ideology? Well, you can't answer that because you've already put in person ID, and that takes care of everything. So it controls for it, but it does so in a way that I think is dissatisfying if you're actually interested in why people differ from each other. The other part of that is that when people do fixed effects, they usually are talking about main effects only. And that means they've controlled for intercept person dependency, but not necessarily any kind of slope dependency. So if you have people who differ systematically in how they change over time, or how they react to hunger over time, or anything else over time, the proper way to extend that control would be to put in person ID by time, or person ID by hunger, or whatever interaction terms. Then you've controlled for that as well. But there's not a whole lot that's left at that point. So the latter part of the interactions is not as well recognized, but it is in fact a thing. So when would you do it this way? I can think of 2 reasons. One is that you have very few people. And 15-ish is the guideline that is given in popular multi-level modeling textbooks. That's not based on anything other than, like 15-ish. So this is a common strategy if you have clustered data that you don't want to be clustered. Like if you were interested in, say, let's go with the higher education, you're interested in a particular kind of student from a particular kind of background, but that's not a very common kind of student, and let's say you have to recruit across 5 different universities to get a decent sample size of that kind of person. Well, you don't care about university, you just had to expand your sampling to get the numbers. So in that case, you would put in which university is which as a fixed effect like this, and then you're done. And you could put in university by time to control for any of those differences, and you're done with that. So if you have very few units, people in this context, but it holds across the board, then this might be a reasonable strategy. Another is if you actually care about the individuals. So in the kinds of research that folks do in behavior analysis, or what is known as N-of-1 randomized control trials, I linked to a paper here that I wrote with a former student and one of his friends. Like if you're doing some kind of treatment study and you really want to talk about how, Sarah improved and Bob improved, and you're not interested in making comparisons, you're not interested in generalizing, you want to talk about these specific individuals, then this is an approach that would allow you to do exactly that. Same thing in the context of if I want to talk about how the College of Education differs from the College of Engineering differs from arts and sciences. Like very few units that are meaningful to the analysis as that unit. Then a fixed effect approach where you're not trying to generalize, you're not trying to extend is what you want. but only in those certain situations. So questions on that? Have you seen this kind of thing used in practice before? Maybe? Yes? When have you seen it? What?
When I did it for the,
When you did it?
yeah,
When did you do it? I'm trying to remember.
in the summer, the items and people.
Oh, the items and people. Yes. Can you tell the story and say it loudly so everyone can hear you?
If I remember.
Yeah, that was all the way last summer ago, I know.
I had a design with people taking multiple items.
People took multiple items. I'm translating for the Zoomers here.
And then I didn't really care about the items, so I put in fixed effects for the items to just look at the difference, the fluctuation for the people.
So didn't care about the item, so you just controlled for which item it was and then went about your business. Yeah, in that kind of design, you would have responses nested in people. Responses are nested in items, and people and items are actually crossed at level 2. But if you only have 5 items, then you put in which item is which, that cross dimension goes away. And yes, Dan, you should be listening to this. It's the same thing we talked about yesterday. That dimension goes away, and what's left is just the level 1 part, which is technically the interaction of person by item at that point, because you've removed constant item differences related to which is which. So yeah, if there's only 5, then that's a reasonable thing to do. But if you had wanted to predict why some items are more difficult or responded to faster than others, that's an explanatory item response model looking at you, Ahmed, then you would not want to do that. You would want to keep it as a random dimension and then put in predictors as to why some items are different than others and see how much variance you can explain by doing that. Okay, so it's a viable approach, less useful if you actually care about the differences between the sampling units. The other is to not think of it as a multi-level problem, but think of it as a multivariate problem. So if I have a study in which, let's say there are 4 tasks, I'm going to stick with the examples that are fresh on my mind. Let's say that I ask a student to write 4 different essays. One might do that. So that's like repeated essays within person. It's not longitudinal, but it's repeated measures. In that context, random slopes and intercepts don't make as much sense as just saying, I have 4 outcomes. So in that case, you have balanced data because everyone responded to the same kinds of prompts or completed the same possible writing tasks. And so if you're sticking with the world of repeated measures ANOVA, then you have 2 choices, compound symmetry or unstructured. Either we say that the variance is the same across tasks and the covariance is all the same, or we let them each be whatever they want. If you were to estimate the model using traditional ordinary least squares, though, that would require listwise deletion for anyone who didn't complete all 4 tasks, and that's bad. So if we switch to some kind of likelihood estimation, or Bayes, because that is likelihood with priors, it's not different, it's just adding another layer to it, then you have more choices. So I can think of it as still a multivariate problem and try out different kinds of structures like maybe compound symmetry heterogeneous. That's where the tasks are equally correlated, but some of them are more variable than others. And you can use likelihood ratio tests, AIC and BIC, to distinguish among these potential alternatives. If you don't have time as a repeated dimension, though, the rest of the ones we talked about last semester probably don't make any sense. But if I went with this approach, I would think of it as a single level model predicting 4 outcomes at the same time. So it's multivariate single level. Thoughts or questions on that? Okay. And then third, what we're here to do, what we've been doing, add a level. So if I have occasions nested in persons, I can think of that as one thing, like I've measured hunger at repeated occasions, or I've measured negative affect at repeated occasions, and then I have univariate multi-level instead. So I'm using random effects to capture the dependency, to introduce it into the data. So if I add a random intercept, that says all outcomes from the same person should be equally correlated. If I add a random slope, that introduces differential correlation as to which outcome type it is, so occasion type or other kind of repeated measure, and heterogeneity of variance. So cough, cough, homework question. Random effects then